Find the minimum value of force F acting on block at an angle theta with horizontal as shown to shift the block. So what is the question? So there's a rough horizontal surface. I have kept a block of mass m. Then I applied a force at an angle theta. Is asking the minimum value of this applied force so that the block will shift. So what is this? Is it a pull or a push force? It's needed in some applications. Needed. Why don't question the concept? In some applications it's needed. That's why we are just have that information. Now you have to find out the minimum value of force F that should be applied on the block so that to shift the block. So what is the question asks? Minimum, what minimum pull force? So you look at this one. Is it a push or pull force? It's a pull force here. So if you want, I'll write it very clear. Pull force. So we'll we'll do one thing. We'll resolve this force F into two parts. So one force will be, I'll draw the one separate diagram. So this is the normal reaction. The weight mg. The rough surface. We have kept it rough with quotient of friction, limiting friction. Let it be mu s. And what action the friction should act? The friction should act in this direction. By the ground, on the block. By the block, on the ground will be in this direction. And usually we are not interested to show that. Okay, fine. So I'll take it on this. This is the normal reaction. So when I resolve that force, so how much here? F sine theta, F cos theta. When the block will shift, when F cos theta is equal to F or greater than or equal to F, let's assume. So then mathematically first we'll calculate N plus F sine theta minus mg cos 0, or N equal to mg minus F sine theta. Or along horizontal direction, F cos theta should be equal to F. Further, what is F? Mu s n. So here F cos theta equal to mu s. What is n? This is equation 1. Substitute 2 in 1. So this should be mg minus F sine theta. So where this F is equal to mu s mg by cos theta minus mu s sine theta. Is asking the minimum. So what to do now? I'll differentiate this. Let me differentiate this. So differentiating this df by d theta.
Won't it be plus?
Yes, sir. Plus mu s sine theta.
N is equal to no n plus. So you look at this, n plus f sine theta minus mg cos 0, no?
Sir,
Sir, in the denominator, sir.
minus mg. Minus mg minus f sine theta.
Okay, that one. Yeah, this will be f cos theta. F cos theta equal to mu s n, no?
Yes, sir.
F cos theta is equal to mu s n, and substitute the value of n, mg minus f sine theta, and there should be the plus. Okay. Denominator plus it should come. So now
Sir?
let me differentiate. Yeah.
Sir, f cos theta should be greater than or equal to mu s n, right?
Yeah.
For it to shift.
Yeah, yes.
Okay, sir.
So now I'll differentiate this. So this will be mu s mg by cos theta plus mu s sine theta whole square minus of derivative of this. Derivative of this will be minus sine theta plus mu s cos theta. So now what is the condition for maxima? Df by d theta, let it equals 0. So equating the numerator part, minus sine theta plus mu s cos theta equal to 0. So what is tan theta now? So we'll get tan theta as mu s, or further I can write it as mu s by 1. So let me go for triangle. This is theta, this is mu s, this is 1. So this will be 1 plus mu s whole square. So what is sine theta? Let's have these values, because I should substitute the value of theta in this equation, no, to get that minimum force. So sine theta should be equal to mu s by root of 1 plus mu s square. Cos theta is equal to 1 by root of so let me substitute all the values. This should be equal to now I'll call f minimum that one. So mu s mg and this will be cos theta 1 by root of 1 plus mu s square plus mu s sine theta mu s by root of so what is the f minimum now? So total f minimum should be equal to 1 plus mu s square will come. So this should be the final resultant will be mu s mg by root of 1 plus mu s square. So this will be your answer. What I did, I substituted sine theta, cos theta value in the okay, everything, all the total derivation is here. We have substituted the this particular values, no, sine theta, cos theta, we have substituted at this place. Then solving for that, will end up here. Here 1 plus mu s square will come. 1 plus mu s square in the denominator, what happen? It will be 1 plus mu s square, root of that one. So we'll end up with this one. So there's a minimum force, you see. And at what is the angle? What is that angle? I should apply it an angle theta tan inverse of mu s. Okay, fine. So this is the. So do remember, this is something very important here. This is a pull force. What is the minimum pull force you should apply? So if you apply at an angle, then what will happen? It will become minimum. Any reason for that? I think it's quite clear, no? When you apply force, if you pull horizontally, what is the force required? Mu s mg. But when you apply, see when you apply force horizontally, what is the minimum force required? Mu s mg. When you apply force at an angle, why do the force will become less than mu mg? Because the component of f sine theta, what it does, it will decrease normal reaction. Then what happens? With less effort, we can pull the block very easily. Trying to analyze, there's a mathematics, we got answer. If you pull the block horizontally, what is the minimum force you needed? Mu s mg. But can I pull the block with with a force less than mu s mg? Then I should pull the force at an angle theta with horizontal. And what is the theta? It is giving. So it should be made this much angle. It's not angle of friction again. Don't get confused here. It's not angle of friction. Previous case also we took theta. There it was different. Here there's a situation different here. So what is that angle at which I should apply the force? Tan inverse of mu n. That one is telling one specific angle is there. Then how much of that force? Mu s mg. Is it less than mu s mg? Yes, it is. So the question will be asked, find the minimum pull force required to pull the block. Will you write mu s mg or will you write mu s mg by root of 1 plus mu s square? You should write this one. Any reason for that? Because a component of F will act vertically, so that will decrease normal reaction. If normal reaction decreases, then what will happen to friction? Will further decrease the value of friction. So here, if N decreases, then the limiting friction acting will decrease, no? Able to understand this? So what is F? F should be equal to mu s N. So so at an angle theta, if I apply, because of F sin theta acting upward, the normal reaction decreases. Then definitely the limiting friction which is needed, that will decrease here. So we are discussing problem for shifting. If you want to write FL, it doesn't matter. It doesn't makes any difference. So here what happened? We are discussing about the problem about to shift. Here the normal reaction I should minimize. So therefore I'm applying at an angle theta. Okay, now similarly, what is a push force? So here we pulled it, no? If I push it, what is the value of F for which you can shift it, that one? I'll give it you, try to work out here. I'll assign you, try this one. Huh? Okay, now look at this force. Is it a push or a pull force? It's a pull force, no?
Push, sir.
Oh, sorry, push it is. Huh? Now I'm pushing it, that one. So definitely what happened, a component of F sin theta will act vertically down.
Sir, it will increase friction, sir.
It will increase friction here, no? You can see that. So shall I, what is the maximum or shall I call minimum here?
Maximum, sir.
What is the maximum push force that I can apply on the block to shift it? It is like this. So that you have to calculate. So let me put it, find the maximum value of push force F acting on the block to shift the acting on the block at an angle theta with horizontal. We don't know this theta also actually. To shift the block. Try to work out. Okay, I'll leave it to you. So try to work out. So this is second case. So here you see that one. So it should be a pull force, push force, no? Earlier it was a pull. Now this will be a push force. Okay, later on you do it. It will be available for you. So I'll go for the next case. Frictional inclined plane.